So, our topic for today is all about indefinite integral. History. The notation for the indefinite integral was introduced by Gottfried Wilhelm Leibniz in 1675. He adopted the integral symbol integral from the letter or long S, standing for summa, written as Latin for sum or total. Indefinite integral. An indefinite integral is a function that takes the antiderivative of another function. The indefinite integral is an easier way to symbolize taking the antiderivative. The indefinite integral is related to the definite integral, but the two are not the same. So, indefinite integral of some common function. Integration is the reverse process of differentiation, so the table of basic integrals follows from the table of derivatives. Below is a list of top integrals. It is supposed here that A and B, C are real constant, B is the base of the exponential function. Properties of the indefinite integral. So if uh, if a is some constant, then integral a f of x dx equals a integral f of x dx. So the constant coefficient can be carried outside the integral sign for functions f of x and g of x. So in integral f of x plus negative g of x dx equals integral f of x dx plus negative integral g of x dx. So the indefinite integral of the sum or difference equals to the sum difference of the integrals. These integrals are called trigonometric integrals. They are an important part of the integration technique called trigonometric substitution, which is featured in trigonometric substitution. This technique allows us to convert algebraic expression that we may not be able to integrate into expression involving trigonometric function, which we may be able to integrate using the techniques described in this section. In addition, these types of integrals appear frequently when we study polar, cylindrical, and spherical coordinate systems later. Let's begin our study with products of sine x and cosine x. So, integrating products and powers of sine x and cosine x. For example, integrating integral cosine squared minus x sine x dx. So, evaluate integral cosine squared x sine x dx. So the solution is use u substitution and let u equals cosine x times, in the case du equals negative sine times dx, x dx. Thus, integral cosine cube x sine x dx equals negative integral u cube du equals negative 1/4 u4 plus c equals negative 1/4 cosine 4 x minus x plus c. A key, a key idea behind the strategy used to integrate combination of products and powers of sine x and cosine x involves rewriting this expression as sums and differences of integrals of the form integral sine squared x cosine x dx or integral cosine squared x sine x dx. After rewriting these integrals, we evaluate them using u substitution. So, a preliminary example, integrating Integral cosine x sine key x dx where key is add. Evaluate integral cosine squared x sine squared x dx. So the solution is to convert this integral to integrals of the form integral cosine g and x sine x dx. Rewrite sine cube x equals sine squared x sine x and make the substitution sine squared x equals 1 negative cosine x squared x. Thus integral cosine squared x sine cube x dx equals integral cosine squared x 1 minus cosine squared x sine x dx. Let u cos equals cosine x, then du equals negative sine x dx equals integral u squared 1 minus u squared x du equals integral u4 minus u squared du. So equals 1/5 u5 equal minus 1/3 u cube plus c. So equals 1/5 cosine 5 x negative 1/3 cosine cube x plus t 3 plus c rather. So the rule integrating products of sines and cosines of different angle. To integrate products involving sine ax and sine bx and cosine ax and cosine bx, use the substitutions. So sine and ax, sine and bx equals 1/2 cosine a minus bx minus 1/2 cosine a plus b and x. Sine ax cosine bx equals 1/2 sine a minus bx negative 1/2 sine a minus b dx. Cosine a and ax cosine bx equals 1/2 cosine a minus bx plus 1/2 cosine a plus b x. And that's all. Thank you.